Great, awesome. Okay, fantastic to be here today speaking with you all, and thanks to A2EP for organising this event. There seems to be a bit of a groundswell with thermal energy storage in industry at the moment, so it's great to have events like this where we can get a good cross-section of what's going on in the market. As Laura said, my name's Furness. I'm the Head of Business Development at MGA Thermal, and I guess what we're starting to see is we're really on the cusp of this industrial renaissance. It's about a quarter of the world's greenhouse gas emissions are sourced from industrial heat, and 90% of that industrial heat is sourced from fossil fuels. So although there's a lot of room for incremental improvements in process efficiency, and that's really important, we still have a need to transition away from expensive fossils. So we really need breakthrough technologies that are going to transform industrial heating and importantly, that offer a really compelling value proposition. So I guess MGA Thermal, our solution is about reliable, economic and clean steam at scale and up to 550 degrees Celsius. So how do we do that? It's really a firming technology. So we charge using that intermittent least cost off-peak renewable electricity. We store that energy as heat in our proprietary blocks, and I'll come to that on the next slide. And then we deliver reliable heat and power on demand on a 24/7 basis. So key verticals that we're targeting are really chemicals, oil and gas, minerals processing, food and beverage, and building materials as well. So how do we get to that? Well, so what you can see on screen at the moment is a cross-section of one of our proprietary MGA blocks. Each block is about the same size as a shoebox, so 5 litres, 10 kilos, 1.5 kilowatt hours of storage per block, and it's made of a graphite matrix with dispersed aluminium particles, and that's what you can see glowing red hot in this image on screen. Now, I guess these blocks have been designed from scratch with the desired properties for thermal energy storage, and that's really a focus on economics, conductivity, energy density, and longevity. And uniquely, these blocks, they embrace the benefit of a phase change while being outwardly solid. So that's that aluminium particle, which melts as we heat our system up and then cools down as we dispatch energy, all the while staying secured and encapsulated within a solid graphite block. If we then step back to the system level, during charging, we use electric resistive heating elements to convert electricity to heat. And then we absorb that heat using our MGA blocks inside of an insulated enclosure made of mild steel. And then during discharge, we use a closed cycle nitrogen gas loop to transfer that heat from the blocks to an off-the-shelf HRSG to generate that high-grade process heat at up to 550 degrees Celsius and well over 70, 80 bar pressure. And I guess there's a couple of key flow-ons from that. So the first one, and a really key tailwind for thermal energy storage is energy density. To give you a number to pin to, lithium-ion batteries have 24 times higher energy density than MGA Thermal's storage solution. The second point around rapid heat transfer, part of the reason we use a graphite matrix is because it has really high thermal conductivity, and that rapidly distributes heat through the system with low thermal stress so that we can get energy in as quickly as possible at least cost, and then dispatch as quickly as possible on demand. We use a large-scale industrial engineering approach, and that ultimately gives us really good economies of scale, as we start to go beyond 30 megawatt hours, even up to gigawatt hour storage capacity for some of the sites that are in development. Simultaneous charging and discharging, really important for flexible operating modes, including 24/7 output. But as Tom and Ian have already pointed to, having these highly flexible assets in the grid is going to be really important to uptake and adoption. And then lastly, replacing key equipment in service, particularly our heating elements, with uninterrupted operation. So I guess we're trying to think about, not just the development of high performance thermal storage materials, but from an overall system design perspective, how do we maximize value to customers and then ultimately allow us to deploy these assets in a streamlined and accelerated way as well? We understand this is a show me, don't tell me industry, and I'm actually super excited to share. We're currently in hot commissioning for our 5 megawatt hour pilot project, which is in Tomago, New South Wales. So it's a shame, Ian, it's just outside of Essential Energies network. We're actually in the Ausgrid network, but that's actually on track for completion in the next fortnight. So we're really close to that. And thank you very much to Arena and to Shell for funding support for that project. This is a really critical milestone for our technology readiness. And actually last week, I mentioned we're in hot commissioning last week, and a very real milestone for us, lifting the maximum operating temperature of our unit up past the phase change temperature, and then dispatching superheated steam at 360 degrees Celsius and 40 bar. So really testing the upper limit of this unit last week, which is super exciting. And I guess the long-term purpose for this demo unit, is really about knowledge sharing. It provides an opportunity domestically here in Australia for stakeholders to come and get your hands dirty with this unit in our sandbox environment. And the performance data from this unit, which will be, a level of that will be publicly available, will ultimately help to promote the business case development for thermal storage here in Australia and abroad as well. Economics, really critical to adoption. And I guess the good news is today, thermal storage is already economically competitive with fossil fuels and competing renewable technologies on an LCOH basis. I guess further to that, we're actually expecting a 30 to 60% cost out of the capex of our system as we scale up. That addresses that navy blue chunk down on the bottom left of the screen on the MGA TES column. But I think, and we're going to turn to some case studies on the next couple of slides, there's actually significant potential upside that can be enabled through thermal energy storage, which is not reflected here in this straight displacement of gas with least cost renewables. Thermal storage is a highly flexible, scalable energy storage asset that can actually drive a step change improvement in the overall process efficiency of sites. It can actually enhance energy security and resilience of those industrial sites. And as Ian has been talking to, it can actually provide grid services as well. So I think what we're finding is we're working through a lot of the feasibility studies with large industrials is that these upside opportunities are seriously moving the needle on the business case for TES and making it a more immediate term prospect. So let's turn to that now. Now, we have NDAs up to our eyeballs at the moment, so I'm going to be anonymizing these case studies, but just want to highlight some of those benefits I was alluding to. This first case study, an off-grid mining and minerals processing site that currently uses gas-fired package boilers for their steam production. The steam is used for their digestion and drying processes on site, but it's actually also used for backup power generation using steam turbines. So I guess part of the problem that they're facing on this site is these package boilers are really not flexible enough for their operation. So for energy security reasons, they need to run these package boilers 24/7 idling on minimum turn down, which for context is 20 tons per hour of steam, so significant energy load. And they do that on minimum turn down ultimately so that they can rapidly ramp up steam generation in the event of a contingency. That 20 tons per hour is not being used on site, it's simply exhausted to atmosphere. So it's a massive source of energy consumption and waste heat. Now, when we look at thermal energy storage, we can ramp up steam generation rapidly, about 25% of nameplate capacity per minute. That's far more rapid than traditional or incumbent package boilers. And ultimately, that means that we can turn those package boilers off minimum turn down to hot standby, saving that 20 ton per hour of steam demand, and use our TES unit to respond rapidly to any contingency event that occurs. So that in and of itself drives a 13% reduction in the annual steam demand from the TES, so a significant chunk. The next example is a building materials site. So I guess for this site, there's actually a significant amount of low-grade waste heat that's currently exhausted to atmosphere due to some operational constraints. They don't currently have a way of recovering and utilizing this low-grade waste heat. It's too low temperature, low pressure to be utilized directly in other processes, and so they currently exhaust that to the atmosphere. Now, in this case, we can actually use our thermal energy storage to produce really high temperature, high pressure steam and we can use that to boost the quality of that low-grade waste heat to sufficient pressure and temperature so that it can be used on site. That delivers a significant improvement in the overall process efficiency of the site. It's about 10% of process efficiency. And in this case, where we are, sorry, I should pause on that because it is a significant chunk. 10% improvement in process efficiency. It's significant, and it's starting to move the needle. The next point, I guess, is on grid services. So this will be a grid connected application, and given the flexibility of that asset, Ian, you were talking before about some of the reverse power flows you're experiencing in different parts of the market. Some of the capabilities of TES start to unlock some of those additional revenue streams through grid services as well. Great. And then I guess second last slide here, just regarding our traction to date. So we just announced our first paid feed study with Chevron Energy, Fortune rated company, to complete. I guess that's for a 5 MWh trial unit for one of their sites in North America. That was delivered in collaboration with Anacapa Engineering, so Chevron's appointed EPC. There's another project which is in development at the moment, 180 MWh deployment, which will be in Western Australia for an industrial zone asset, where that will essentially be feeding steam over the fence to multiple offtakes, with a consortium involved in that pre-feasibility study. The consortium involving an energy company, engineering consultancies, offtakers, and funding and asset owners all lined up for that. So that's super exciting. And then again, thank you to Shell for their support, who provided about $400,000 to support our demonstration unit, which is coming online next month. So yeah, some really exciting milestones coming up for us commercially as well as technically. I guess maybe to close and wrap up, I just want to reiterate that point at the start, that we're really on the cusp of an industrial renaissance. Thermal storage is more than just electrification. It's a highly flexible, large-scale storage asset that can drive a step change improvement in overall energy efficiency, reliability, security, and sustainability. And we're finding, particularly as we dive into the detail with a lot of industrials, that's what's really moving the needle. So whether you're interested from a collaboration or a client perspective, I really do welcome your contact, and thank you again to A2EP for having us.